So this is the last page of the practice test that I didn't put in my initial videos. Here we go. The last electron in the filling order for an element has these quantum numbers. So n equals 4. So let me remind you that if n equals 4, that L can be 0, 1, 2, or 3. Remember we called L equals 0 was an S sublevel, L equals 1 is a P sublevel, L equals 2 was called D, and L equals 3 was called F. Of course, for each one of these L values, there are M values. And M can be from negative L to positive L. And L, by the way, was 0 to n minus 1. So that's why if n equals 4, you can go from 0 to 3. But you can't go to 4 because n minus 1, 4 minus 1 is 3. All right, so from negative L to positive L, when L equals 0, M has to be 0. But M for L equals 1 could be negative 1 or 0 or 1. So it's like there are 3 beds in the pink room. Then if L equals 2, that could be negative 2, negative 1, 0, 1, and 2. So there would be 5 rooms or 5 orbitals in the dark room, the D sublevel. And for F, negative 3, negative 2, negative 1, 0, 1, 2, 3. So there'll be 7 beds or 7 orbitals in the fine room, the F sublevel. So now we're going to look at these particular quantum numbers. We have n equals 4, L equals 1. L equals 1, so it's a P sublevel. So we're talking about the 4P sublevel. All right, so 4P sublevel means that we are on the right side of the periodic table. And let me grab a periodic table and show you. The periodic table, and 4P is here, and L equals 4P. We're somewhere over in here. We don't know where, but 4P. So there's 4P. L is 1. All right. So and now we know that M equals 0. So let's look at the M equals 0 possibilities. I'll write the 3P orbitals out. Negative 1, 0, 1, and we said by convention we're going to start negative and go to positive. And the S value is positive 1/2. The S stands for the spin. So for each one of these values of M, there are 2 S values, positive 1/2 clockwise, negative 1/2 counterclockwise. So in this case it's positive, and we said by convention we're going to put electrons in clockwise first. So we start putting them into the P sublevel, and we stop right there because that's the clockwise, first one in clockwise. And we move from left to right, and we are stopping then when we hit the positive 1/2 electron. So that would be the 4P position, 4P2, 1, 2. So if you look over here, 4P2 would be germanium, 4P1, 2. All right, so let's write the complete orbital diagram for showing all the electrons in that atom. 1s, we're going to go straight through the configuration. So 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 2. So we're going to go to there. All right, 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. Now we'll put the orbitals in by using the circles because they're easier to use. Why did I put 3 circles here? Because there are 3 values of M. For L equals 1 value, a P sublevel, 3 values. 1, 3 for the 3P, 1. How many circles will I put for the 3D? And then the 4P would have 3 again. And you put the electrons in. Now I'm up to 30 electrons. Electron number 31 and number 32. Number 31, number 32 have to go in by themselves, and that's your orbital diagram. All right, now we're looking for N, L, M, and S for aluminum. The next question down. So aluminum is element number 13, and we can see it's in the 3p row and it's position 1, so 3p1. So now we know N, L, M, S. We know that N is 3 and L is 1 because it's in the P sublevel. And for a P sublevel, L equals 1 right here. The M value when L equals 1, M can be negative 1, 0, or 1, but we said we're going to go by convention, negative, 0, positive. So negative 1 is the first one. And it's got a positive 1/2 spin because it's the first electron in that sublevel. So the p sublevel of aluminum would look like this. That's the pink room with 3 beds. One person in the first bed, so that would be negative 1, because we said we're going to go in order, negative 1, 0, 1. And the S value would be positive 1/2, because aluminum would be, there's only one electron in the 3p, and that has to be in the first orbital spinning clockwise. Remember, it's going to go clockwise, 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 counter, counter, counter. Draw a picture of a complete p sublevel, including all orbitals. So the p, so really what we're saying is, what do these 3 orbitals look like? Here they are. You have a dumbbell shape laying on the x-axis, like that. So I'll put these axes in here. Z, there you go, X. We'll call this one X. We'll call this one Y. We'll call this one Z. All right, so there's the x-axis, and we have a y-axis orbital. Be like that. And then the z-axis would be perpendicular like this. So there's your p sublevel. Next, let's draw a picture of a 1s, a 2s, and a 3s orbital. So they're all, s orbitals are all spherical. So I can't really draw a sphere, but kind of like that. And then the 2s would be bigger, kind of like that. And the 3s would be bigger still. Now, of course, inside these, there are some, these are all really waveforms. So there's, visualize a wave going through, but the outside would make this spherical shape, kind of like that. Okay, now we're going to draw an orbital diagram for an atom of 10, Sn. So Sn is right here. It's element number 50 on the periodic table. So we need to put in 50 electrons. We know it's going to end in 5p. See, it's in the 5p2 position. So here we go. So 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4p, no, 5s, 4d, sorry, 4d, and then 5p, and that's where 10 will stop. It's in the 5p position. So how many circles will I draw for all the s's to show the orbitals? All the s's get 1 circle, because the s sublevel just has this 1 orbital. How many circles will the p's get? Well, the p sublevel has 3 orbitals, so each orbital is represented by a circle. Now I already put in the d's. So the d's don't show up until the 3rd energy level, and how many beds do they have? Remember back up here that the d's have 5 values, negative 2, negative 1, 0, 1, and 2. So we're going to draw 5 for the d's. And now we just put the electrons in. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. Now the next question is, how many electrons in this atom have an m sub L value of 0? So what I think I'll do is I was going to look for a highlighter, but I don't see a highlighter in my drawer, so I guess I'll just use my other pencil here. So the ones that have, I'll put a little underline under the ones where m equals 0. Let's go back up here. M equals 0 for all s orbitals. M equals 0 for one of the 3, the middle one of the p orbitals. M equals 0 for the middle one of the d orbitals. M equals 0 for the middle one of the f's, but we don't have any f's, so it would just be these that we're looking for. So there's 2, there's 4, there's 6, and these are the, I'll put a square around the m equals 0 orbitals. So all the s orbitals are m equals 0. The middle orbital on the p is m equals 0. The middle orbital on the d is m equals 0. middle orbital on the p, all the s, middle on the d, middle on the p's. So how many electrons in this atom have an m sub L value of 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 21? So that answer is 21. That there are 21 with the m sub L value of 0, or m value of 0. And then remember I left off the light. I have a previous video, another point on the web page about how to do these, but I didn't put these on the exam, so you're home free on those. So I think that's all I need to say about this back page. Study for this test.